In this video, I'm going to go over the end behavior in polynomials. The first thing we need to know is, what does end behavior mean? Basically, that just means when we draw the function, or when we draw the polynomial, what does it look like at the edges of our drawings, where it goes off where we can't see it from our drawings anymore? What will it look like at that point? And in order to figure that out, there are two things we have to look at. The first is the degree of the polynomial. Now, the degree, if you recall, is the highest exponent in the polynomial. For example, from this function, this polynomial that I put up here, the highest exponent is 4. The little up arrow 4 means exponent, in case you don't know. So we have our degree is 4, and we want to know whether that is even or odd. Obviously, 4 is even, so even means that the ends of it will be going in the same direction, like you see with these green arrows here. Or, like you see with these arrows, they're both going up or they're both going down. So if the degree is even, they're going the same direction at the ends. If the degree is odd, they're going in different directions. Like we see with these green arrows here, one end is going down, one end's going up, one end's going up, one end's going down. How I like to remember that is that opposite and odd both start with O, so these are going in opposite directions. Now, the other thing we can look at is the leading coefficient. We want to know whether the leading coefficient is positive or negative. So if it's positive, we have an overall theme of going up. Like you can see right here, both ends of the function are going up. Right here, even though they're going in opposite directions, if you read from left to right, the right side will be going up overall. Like when you have a straight line and your slope is positive. And then obviously, if the leading coefficient is negative, you have the opposite. It will be going down. So either both sides will be going down, or it'll be going down left to right, like a negative slope, if you will. These blue ones that I have drawn here are just possible examples. You can see how this is if something has an even degree and a positive leading coefficient, you'll end up having them going the same direction, and they're going up from the positive. However, I just drew this crazy thing here to show that this is not the only option with that. And then we sort of have the opposite, where it's negative, which means it'll be facing down, but it's still even, so they're both facing the same direction. We don't really know what it's doing in the middle here. That's why I drew those like that, because we really don't care. What we're looking at is the ends, like I drew in green. And then to look at these examples, if we have odd degree, that means they'll be going in opposite directions, odd opposite. So we can see here, both those ends are going in opposite directions. And if the leading coefficient is positive, we have sort of an overall upward direction from left to right. So you can see as you're moving closer to the right, it goes up. On the right, it goes up. But again, these don't tell you anything about really what's happening in the middle. That's why we're calling this end behavior, not anything to do with the middle. And for the last example, we have the odd degree, the opposite direction, and we have a negative leading coefficient. So it goes overall down. So on the right side, it'll be going down. Now, looking back to our example here, we have, as we discussed earlier, an even degree of 4, and our leading coefficient right here is positive 1. So we have positive and even, so it's going to look more like one of these, or it's at least going to look like this at the ends.